Hello everyone. In this video, we'll be talking about the communication system. Before we dive deep into the concepts of the communication system, let me ask you a brilliant question. The farting and the loose motion of the sun can shut down the global internet, the global positioning system, and the power grids. It can cause the blackouts. How? Do you know? If you have any idea about it, let me know in the comment box. Although in this video, I'll be discussing such concepts in detail. So here is the outline of the video. First of all, we'll talk about the meaning of the word communication. Then we will see the basic types of the communication system. There are two types of the communication system, point to point and the broadcast communication system. After that, we will go through the terminology used in the electronic communication system. Toward the end of this video, you'll get one checkpoint and its answer. Getting it? So let's begin. The word communication means the transfer of the information. This word communication pervades all the stages of the life of all the living creatures. For example, consider the human beings. A baby communicates with mother by crying or by the hand gestures or by the gestures of the eyes. As a kid, the student communicates with the teacher, writes the answers on the notebook, the teacher evaluates. The better a student communicates, his marks or the grades will be better. And then for the professional life, when a person goes through an interview, his chances of selection or rejection depends how well that person is communicating during the interview. Even in the appraisal cycles of the jobs, they check your communication skills. The better you can communicate with your higher authorities, the better appraisal you will get. I hope you understand this. Then in married life, the peace, I repeat, the peace depends upon how well a person can communicate with the partner. So communication is an essential part of the life. Got it? Since we are using numerous electronic communication systems in our daily lives, for example, the internet, the mobile, the TV, so it would be unwise to attempt to study the detail of all such communication system. Instead, an efficient way would be going through the basic block diagram of all communication systems. So here is the diagram. First of all, on the left hand side, you can see an information source. This information source will deliver the message signal or intelligence, which could be an audio file, a video file, or some computer signal, etc. Got it? The message signal is passed to the transmitter, and then transmitter transmits the signal through the channel, which then reaches to the receiver end, and then finally it goes to the user of the information. For any communication to be successful, the receiver and the sender must understand a common language. For example, right now we are communicating. I'm transferring some information to you. And since you understand the English very well, you understand whatever I am telling. Now let me speak something in a different language. Jai Baberi. Okay. Now, do you understood the last three words which I spoke in different language? If you don't understand that second language, you might not understand what I was trying to communicate. So keep in mind, for communication to be successful, the receiver and the sender both should understand a common language. Now we'll see the two basic types of the communication system. Number one is the point to point and number two is the broadcast. In the point to point communication, there is a single transmitter and the single receiver. For example, controlling a drone, the operator of the drone sends some signal to the drone. So here is one transmitter as well as only one receiver. Okay. I request you to post few more examples of the point-to-point communication system in the comment box. Second is the broadcast. In the broadcast, there is a single transmitter but a large number of receivers. For example, this mode of communication. I am the single person who is recording this video and transmitting it over the YouTube. Then YouTube is broadcasting it in the entire world. Or the cricket match, the televisions, the cricket match are broadcasted on the television. There is a single source in some stadium, the match is being played and then it is being broadcasted to many receivers around the globe. Got it? Now we will see the basic terminology used in all kinds of electronic systems. The number one is transducer, which converts the energy from one form into another. For example, I am using this microphone. It is converting the pressure variations of the air into the electrical signals, and then you are receiving these signals, and at your end there is a speaker. That speaker is converting the electrical signal into the pressure variations. I hope you understand. So at your end, the speaker is serving as a transducer. At my end, this microphone is serving as a transducer. Can you name few more transducers? Let me know in the comment box. The second important term is the signal. When the information is converted into the electrical form, it is termed as the signal. There are two types of this signal, the analog signal and the digital signal. The analog signals are the continuous variations of the voltage or the current. For example, the audio signals, the video signals in the TV, they are the analog signals. Okay. The digital signals can take only discrete stepwise values, either high or low. And this high and low is indicated using the binary digits 0 and 1. 0 means low and 1 means high. Suppose if we talk of the voltage level, and the low voltage level is minus 5 volt and the high voltage level is plus 5 volt, then wherever the circuit has the voltage level minus 5 volt, that we will designate as 0. Wherever the circuit has the voltage level equal to plus 5 volt, that we will designate as 1. Got it? The computers uses the binary coded decimal systems. Now let's talk about the channel. Channel is the medium through which the signal is transferred. For example, we can use the space as the channel. For the satellite communication, the signals are transferred through the space. The copper conductors or any kind of conductors can also be used to transmit the signals. To transmit the TV signals, we use the coaxial cable. To transmit the broadband signals, we generally use the optical fibers. And to transmit the sonar signals, the water is used as a channel. To transmit the AM, the amplitude modulated waves, the earth surface is used as a channel. So there could be numerous examples of the channel. Next important term is the transmitter. Transmitter processes the incoming message signal and makes it suitable for transmission through the channel and the subsequent reception. Okay. Next term is the noise. Noise means any unwanted signal that tend to disturb the transmission or the reception of the information. The noise is a general term, it's a broad term. Any unwanted signal in the system will be termed as the noise. Got it? The example of the noise is familiar to you. During the bad weather, the reception of the TV signal, if you see, there is a disruption, there is some noise, the picture quality is not that much clear. Okay. Next important term is the range. Range is the largest distance up to which the signal can be transferred with the sufficient intensity. Next term is the attenuation or the degradation. When the signal is transmitted through a channel, the strength or the amplitude of the signal keep on decreasing. This is known as the attenuation or the degradation. Next important term is the gain. The gain means the increment in the amplitude and the subsequent strength of the signal. It can be done using an amplifier. Here you can see the amplifier. Basically, the gain A is written as output divided by the input. So we can write the gain in the power as the output power divided by the input power. The gain in voltage is equal to output voltage divided by input voltage. The gain in current is equal to output current divided by the input current. And the electronic circuits usually have the gains often in excess of 1 million. So to make the figures look smaller, they are usually written using the decibel and the logarithm. It makes the computation easy. So you can see few formulas in the decibel form also. Got it? You may note down these informations, then I'll be taking up questions on the gain. Here is the first question and it's a simple one. There is an amplifier where the input voltage is given as 30 microvolt and the output voltage is given as 750 millivolt. We have to compute the gain. It's pretty easy actually. The gain A will be equal to the output voltage divided by the input voltage. Okay. Output voltage is 750 millivolt. Input voltage is 30 microvolt. We can easily simplify these things. It will come out to be 25,000. See the number. The gain by this electronic circuit is very large. Okay. You note it down. Then we'll take up the second example of the gain. Here we have the second question on the amplifier. We can see the input of the cascaded amplifiers as 1 millivolt and we need to obtain the output voltage. If you wish, you may pause the video here and give it a try yourself, then I'll be simplifying it. I hope you all got the correct answer, which is equal to 60 millivolt. So I'm doing the computation here. The solution is pretty simple. Formula for the voltage gain is known to us. A can be written as V out by V input. Do you agree? So for this 5, this gain, we don't know the output voltage. I'll write it V out, but we know the input voltage, which is equal to 1 millivolt. So the V out here is equal to 5 millivolt that I am writing here. The output voltage is 5 millivolt. This 5 millivolt is the input for the second amplifier. So let us do the calculation here. 3 is equal to, we don't know the output here. So I'll write it V out divided by the input is 5 millivolt. So the output becomes 15 millivolt. Do you agree? Then we go for next calculation. This 15 millivolt is the input for the third amplifier. So we can write 4 is equal to V out divided by the input, which is 15 millivolt. V out comes out to be 60 millivolt, which is our answer. I hope you understood it. If someone asks us how much is the total gain of this cascaded amplifier circuit, what should be our answer? Can you guess? The total gain of this cascaded amplifier circuit is A1, A2, A3, which will come out to be 60. You can check the calculations yourself. Multiply them. 5 into 3 into 4 gives you 60. And suppose all these amplifiers are replaced by a single amplifier having the voltage gain is 60. Then what will be the output of that amplifier? Input is 1 millivolt. Output will become 60 millivolt as the gain was 60. Got it? Simple and easy question. You can note it down, then we'll go further. Here is the next question. If you wish, you may pause here and give it a try yourself. It's a simple one. I hope you all got the correct answer, which is 6.8 watt. Let's see the solution here, as the calculation is pretty simple. The total gain of such cascaded circuit can be written as P output by P input, and in the LHS what we should put? 5 into 2 into 17. Do you agree? The P output is unknown. P input is given to us, which is 40 milliwatt. So we'll get the P output. It is equal to 170 into 40 milliwatt, which gives us 6.8 watt. Got it? So these are the simple questions. Once you note it down, we'll take few questions on the decibel figures of the amplifiers. Okay? It's a simple question, so I request you to give it a try. Then I'll be simplifying it. I hope you got the correct answer as 50 millivolt. I'm doing the calculations here. Solution is pretty simple. We remember the formula. Here, this gain is given in the decibel as 60. And then 20 logarithm base 10 V out by V in. Okay, we can simplify this. 3 is equal to log base 10 V out by V in. Fine. This I am rewriting as log base 10 and the number here 10 and the power 3. Think about it. It's a property of logarithm. If you remember the properties of logarithm, you'll understand it very easily. Okay. Now, what is the advantage of doing this calculation? Here is a log function in LHS with the base 10. Here is a log function in RHS as the base 10. So we can compare these brackets. Clear? I am doing that here. 10 to power 3 is written as V out by V in. So V out is equal to 10 to power 3 multiplied with V in. V in is given as 50 microvolt. So the V out will be equal to 50 millivolt. Okay, note it down. Then we'll take up the next question. Here is the last question on the amplifier circuit. We can see two amplifiers and their respective gains. The signal is transmitted through a channel having length 5 km, and in every kilometer the loss is 2 decibel. We need the output power of the signal if the input power of the signal is 1.01 milliwatt. It's a simple question. I'll be simplifying it. In the circuits where we are using the data in the decibel, the overall gain of a circuit is simply the addition of the individual stage gains and the attenuation factors. For example, look at this circuit. Here are 3 devices connected, and if someone is asking you the total gain of this circuit, then what you should do? A1 plus A2 plus A3. A1 is 15. A2 is minus 20 and A3 is 35. Minus 20 meant that this device is causing the attenuation. Okay. Now you add the parameters and you will get the total gain of the circuit as 15 minus 20 plus 35. The answer will be 30 decibel. Got it? The same concept will be utilizing here. Since the data has been represented in the decibel, so first of all, I'll be finding the A total of the circuit, which will be equal to 10 decibel plus here, since there is a loss, we should use a negative sign, and per kilometer the loss is 2 decibel. So in 5 kilometer, how much is the loss? 2 decibel per kilometer into 5 kilometer. I think everyone understands that calculation. Okay, and then the next gain is 20 decibel. I am explaining this calculation once again. 10 decibel this gain, and then the loss here is 10 decibel and the gain here is 20 decibel. So the effective gain is actually 20 decibel. Now this 20 decibel I am talking about, this will be written as 10 log 10 P out by P in. I hope you remember the formulas. This is getting cancelled out and I am rewriting this in a suitable form as log base 10 and then this power 2. This 2 I am talking about is equal to log 10 P out divided by P in. Okay, we can compare. In the LHS we have a logarithm function, in the RHS we have the logarithm function, their base is same, so we can compare this data. That calculation I am doing here, pay attention. 10 to power 2 is equal to P out divided by P in is 1.01 milliwatt. Is it okay? So P out comes out to be 10 to power 2 into 1.01 milliwatt, which is equal to 101 milliwatt. That's the simple answer. I hope you understand that. Now we'll talk about the last important term of the communication system, the repeater. Repeater is basically a combination of the receiver, the amplifier and the transmitter. These are used to extend the range of a signal. For example, a communication satellite in the space is actually a repeater. What happens with the communication satellite? It receives the signal from somewhere and then it amplifies that signal and then transmits that signal to the suitable user. Got it? Another example of the repeater is the repeaters used with the optical fibers. You can see a map here. The lines on these map, what they represent? Any guess? These are the optical fibers laid down on the seabed. Almost the entire backbone of the internet is these optical fibers. And these optical fibers can have the lengths as great as 40,000 kilometers, 50,000 kilometers or even greater than that. Then to boost the signals, the repeaters are connected after every 50 or 100 or 150 kilometers. These repeaters are fed the power using the conductors. And if you understood these two repeaters very well, you can answer the opening question of this video. The solar flare and the coronal mass ejections are the two phenomena which can shut down the entire internet, which can shut down the power grids, which can shut down the global positioning system. How does that happen? Let's have a close look. Here you can see the definition of the solar flare. The solar flares sends the radiations into the ionosphere, which tends to disturb the satellite communication, or even it can disrupt the entire electronic equipments of a satellite. Got it? Solar flares do not have any effect on the optical fibers or the terrestrial communication. The second term was the coronal mass ejection. In the coronal mass ejection, highly magnetized plasma, mainly consisting the protons and the neutrons, comes out from the sun and it is directed toward the earth. Now this can induce geomagnetically induced current in the earth's surface, and these currents can enter into the neutral wires connected to the transformers and can disrupt the entire power grid. These currents can enter into the conductors connected to feed the power to the repeaters of the optical fiber system, and that can take the repeater down. And when the repeaters are down, the entire optical fiber cannot transmit the signal at good strength, so the internet will be shut down. So if the solar flares have a class X, or the coronal mass ejection has very high intensity directed towards the earth, we can have a blackout, radio blackout, as well as the power blackout with the internet blackout on the entire earth. I hope you understood the answer. More details you can Google out. Done? Now let's talk about the bandwidth of the signal. The portion of the electromagnetic spectrum occupied by a signal is known as its bandwidth, or in simpler terms, the bandwidth is the range of the frequencies over which an electronic instrument operates. Okay, your mobile operates on a particular bandwidth. On the box of the mobile or in the description sheet, you can find the data. Another popular definition of the bandwidth is the difference between the upper and the lower limits of the frequency of the signal over which the electronic instrument operates. For example, old telephones, they operate on the speech signals, and the bandwidth of that speech signal is around 2700 Hertz, because the upper limit of the speech signal is 3000 Hertz and the lower limit is 300 Hertz. The difference is 2700 Hertz. That's the bandwidth of the speech signal. Got it? The musical signal requires a bandwidth of around 20,000 Hertz or 20 kilohertz. The video signal for the transmission of the pictures require the bandwidth of around 4.2 megahertz, and a TV signal contains both the audio as well as the video, so it requires a bandwidth of around 6 megahertz. These are few basic informations which we should learn. Okay, on the previous screen we had a talk about the bandwidth of the analog signals. Now we'll talk about the digital signals. A digital signal looks like as shown here. Fourier analysis tells that a digital signal, like as a square wave, can be constructed using a sine wave at the fundamental frequency of the square wave plus an infinite number of odd harmonics. This indicates actually infinite bandwidth. Let us see via it diagram. Here you can see a sine wave which is at the fundamental frequency of the square wave. Got it? Now I am making another diagram in which we have the sine wave at the fundamental frequency plus the third harmonic of the sine wave. You can check it. Then the next diagram has the sine wave at the fundamental frequency of the square wave plus third harmonic plus fifth harmonic. Got it? Then the next diagram, now we have sine wave at the fundamental frequency of the square wave plus third harmonic plus fifth harmonic plus seventh harmonic, and in the next diagram we add the ninth harmonic and then 11th and then 13th and then 15th and then 17th and then 19th, and if we keep on doing the addition of the odd harmonics, see what we get as the end result. We almost get a perfect square wave. So Fourier analysis is a very powerful tool. I hope you understand this thing. Now I am showing you the Fourier analysis expression of a square wave. As you go for the higher harmonics, their amplitude is decreasing. For example, you check the third harmonic, its amplitude is 1/3 of the amplitude of the fundamental wave, and if you check the fifth harmonic, its amplitude is 1/5 of the amplitude of the fundamental wave. So if you check the 17th harmonic, its amplitude will be 1/17th of the amplitude of the fundamental signal. Got it? The fundamental wave. So the contribution of the higher harmonics can be neglected, and this limits the bandwidth of the digital signal. Theoretically, the bandwidth is infinite. Why? Because the digital signal is constructed using a sine wave at the fundamental frequency of digital signal plus the infinite number of the odd harmonics, and practically the bandwidth is limited because the contribution from the higher order harmonics is negligible as their amplitude keep on decreasing with the increasing number of the harmonics. Got it? Now here we have the last topic of this video, the bandwidth of the transmission media. As the different message signals have the different bandwidth, similarly the different transmission media will also have the different bandwidth. Using this table, you'll get the broad idea, and all these numbers are decided by the International Telecommunication Union. On the next screen, you'll get a checkpoint, and then later on you'll observe the answers. I hope you enjoyed the video. Stay awesome. See you again.